Hey there, ever think about your favorite recipe? You know, how every single ingredient, every temperature, every little step has to be just right to get that perfect result? Well, believe it or not, in the world of massive construction projects and heavy engineering, creating a perfect weld is pretty much the same deal. It all comes down to a precise recipe, and that's what we're going to break down today, the Welding Procedure Specification, or WPS for short.
I mean, it's a huge question, isn't it? When you're talking about structures that absolutely, positively cannot fail, we're talking skyscrapers, power plants. Good enough just doesn't cut it. You have to have a system that guarantees quality and consistency every single time. And that system is what this is all about.
So here's how we're going to tackle this. First, we'll look at the why, the recipe book itself. Then we'll follow a recipe's journey from just a rough idea to a fully qualified master. After that, we'll decode the actual document, see what happens if you want to change an ingredient, and wrap it all up with why this whole process is so incredibly important in our world.
All right, let's get right into it. Why can't a super skilled welder just, weld? Why do they need all this paperwork? Well, it boils down to one word: control. When you're building massive structures or high-pressure pipelines, you need absolute, total control to make sure the final product is 100% sound.
And at its heart, a WPS is exactly that, a formal set of instructions. It's the ultimate guide for the welder, telling them precisely how to perform one specific weld to get a very specific, proven result. It basically takes all the guesswork out of the picture.
And this is really the key takeaway here. The goal isn't just to join two pieces of metal. It's to make sure that the finished joint has very specific required properties, things like strength, flexibility, and making sure it won't crack under pressure. The WPS is the blueprint to get you there.
Okay, so you don't just write down a master recipe and cross your fingers, right? It has to be tested, it has to be proven, it has to be perfected. And it's the exact same thing for a WPS. It goes through this really intense qualification process before it's ever allowed on a real job. And this process is no joke. It all starts with a draft, a preliminary WPS. A welder takes that draft and creates a test piece. That little piece of metal is put through the ringer. It's inspected visually, it's x-rayed, it's even literally pulled apart to test its strength. All those results get documented in a special report called a WPQR, and only if that test is successful does that draft get promoted to a final qualified WPS that's ready for the real world.
So what's actually in this master recipe? What does a welder see when they're handed a WPS? Well, it's this incredibly detailed document that covers pretty much every single aspect of the weld you could possibly imagine. Let's start decoding it.
And here you have it. Now, this might just look like some boring form, but it's actually the grand finale of that whole qualification process we just talked about. Think of it as the master recipe card. Every single box, every number on this sheet is a critical instruction that determines the quality of that final weld.
So the whole thing actually starts before a welder even strikes an arc. The WPS gets into the nitty-gritty of the very first step, preparation. That means exactly how the pieces of metal should be shaped and lined up. It also lays out the weld sequence, which is kind of like the layering instructions in a really complex baking recipe.
So this joint design part specifies details like how thick the material is, the type of joint you're making, and the exact angles the edges need to be cut to. It even specifies something called the root opening. That's the tiny little gap at the bottom of the joint. Trust me, every single detail matters here.
All right, next up, the settings for the machine itself. If the joint design is all about prepping the ingredients, then this part is the oven temperature and the cooking time. It is all about controlling the heat.
And that really comes down to a super precise balance between three key things: volts, which control the length of the arc, amps, which control the heat and how deep the weld goes, and travel speed, which, is how fast the welder moves along the joint. Getting this trio perfectly right is absolutely fundamental to a good weld.
Oh, and the list just keeps going. The WPS specifies the exact type of welding rod or wire to use. That's your main ingredient, right? It'll tell you if the metal needs to be heated up before you even start welding. It specifies the type of gas you need to shield the weld from the air, and even the physical position the welder has to be in, like flat or maybe overhead. It's exhaustive, but for a very, very good reason. Okay, but what happens if something on the job calls for a change? What if you need to use a slightly different material or maybe a different technique? Can you just tweak the recipe? Well, the answer is it depends. It all depends on whether you're changing an essential or a non-essential variable.
And this difference is absolutely critical.
See, essential variables are the big ones. We're talking things like the type of metal you're welding or the entire welding process itself. If you change one of those, you fundamentally change the final properties of the weld. You have to go all the way back to square one and requalify the entire procedure. Non-essential variables, they're less critical. You can change them, but you still have to document it in a brand new WPS.
Here's the perfect way to think about it. Changing an essential variable is like trying to swap flour for sugar in a cake recipe. That's not a small tweak, right? You're not making that cake anymore. You're making something completely different that needs its own new recipe and its own testing to prove that it even works. That's an essential variable change.
Okay, so we've gone pretty deep into the weeds here with the technical stuff. But let's zoom out for a second. Why does this super meticulous process matter so much? Not just to the welder, but to every single one of us.
It matters because it is the absolute linchpin for quality control. For the welder, it's a crystal clear guide. For the inspector, it's the definitive checklist. For the engineer who designed the whole thing, it's the guarantee that their vision will be built correctly and safely. And for the client, and really for all of us in the public, it's our assurance of quality and reliability.
You know, the goal of all this work, all this testing, all this documentation, is to get as close as humanly possible to this number, 100%. 100% of welds meeting that required standard for safety, for strength, for quality, every single time.
So I'll leave you with this. The next time you cross a bridge or drive past the skyscraper, maybe just think for a second about all those invisible recipes that are holding it all together. Behind every single one of those welded joints, there's a whole story of testing, of precision, and of a carefully crafted recipe, all designed for one purpose: to make sure it will never, ever fail. It's the invisible procedure that's literally holding our modern world together. Thanks for tuning in.